years old.
All 5 stories. That's the jump.
All right, good morning. We're going to go ahead and get started. And does everybody hear me okay? Okay, so I've been accused of being very soft-spoken. Some of you guys might not agree, but anyway, that's what I hear. If I get away from the microphone and you can't hear me, just yell at me. I'll ramp it up, but I'll try to stay near the microphone just as much as I can. So today, we're doing a virtual tour of the Space Shuttle. So this is going to be real exciting. And you all have gotten a little bit of a taste for this just by riding up and down in our elevators. But when you live here today, you'll know what everything in that elevator graphic actually does. So you're really going to find out what it's like to work and live in the Space Shuttle. So without any further ado, let's go ahead and get started. Now, a little backstory first. I used to work at the Museum of Flight up in Seattle, Washington. And I had the good fortune, once this Space Shuttle stopped flying, of course they distributed the shuttles. We wanted to get one, we didn't get one. But we did get the full fuselage trainer, or FFT. And that's where the tour that I'm going to do a little bit later actually is going to be based. It was constructed in the mid-1970s. And it's a fixed-base trainer that all 355 astronauts who flew into space in the Space Shuttle did a portion of their training in. And it's an exact replica, and the crew compartment is fitted out with actual hardware or reproduced hardware. And it's complete nose to tail, except it doesn't have any wings. Okay? But you can access the crew compartment, you can access the cargo bay, and all of that. And so I was involved with that between 2013 and 2018, and was the person who had to learn the most about the Space Shuttle, particularly the crew compartment, so I could train people who were giving the tours. Because they used to actually give tours, you could get inside the crew compartment and actually experience that. Since COVID, they've stopped doing that. So it turns out that that was a very rare and a very special opportunity that I don't know that is going to be repeated. Okay, so it was originally housed in the mock-up facility in Building 9 in Houston. And there were a couple of other crew compartment mock-ups there too. You can see one on the right, and that one was always left in the down position or the landed position. They had another one that was always left in the vertical position, where the astronauts could train actually getting in and out of the shuttle on the pad. And what was that like? So they had a lot of individual things with individual uses. The FFT, its main use wasn't to learn how to fly in space, but it was habitability training, learning how to live in space. Okay, where am I going to stow my stuff? How do I make food? How do I use the toilet? That's a big one. So all of those things they use the FFT for. I don't know what I just did. Okay. And they would also use the cargo bay occasionally for fit checks on actual hardware that was eventually going to fly, but that we needed to check some things. So it did a lot of work for the program until it came to the museum. And it was so big, you can see that's the Super Guppy, where they're actually delivering the crew compartment section. So 3 or 4 trips with the Super Guppy to get everything there, then everything else came over on a truck, and we had to put it all together. And just to give you an idea of how big this thing really is, there's little old me, and there's big old FFT. The thing is huge, and it's sitting on the gallery floor at the same height and the same attitude that it would have if it were sitting on its landing gear. And I'll get into that later as to why that's important for certain types of training that they did. But when you walk into this room, I mean, that's the first thing that really hits you, as this thing is much bigger than I ever really imagined. It's a large vehicle. 120 and some inches from nose to tail, 19 feet wide, and 46 feet 4 inches from the belly to the tip of the rudder. And when we took delivery of this, there were a lot of really cool Easter eggs that we found inside, and this was the coolest one because it was signed by the crew of the last shuttle flight before they shut down the program. But Yeah, I found little stickers all over the place in hidden places that say "God bless Texas" and stuff like that. So, yeah, it was really fun to see all that stuff for the first time. And now we're looking into the cargo bay, and the cargo bay is huge, 60 feet long, 15 feet wide. The actual shuttle had a payload capacity for the cargo bay of about 50,000 pounds. And it could return, I think it was somewhere, if they needed to return something from space, it was around a 30,000 pound capacity. You could get a full-size school bus inside the cargo bay, no problem at all. And towards the front, where you can see those two little windows, those are the aft crew compartment windows where the astronauts can look into the bay. Along the left side, in its parked position, you can see the Canada arm, okay, so the arm that they could move around to manipulate things. And just below the windows is the external docking adapter. Early flights of the Space Shuttle, they actually used a docking adapter airlock that was internal to the crew compartment, and it took up a lot of space, and that was okay because they weren't docking with anything. But once they started doing that, they needed an external adapter. And so the very top end of the adapter, where you see those metal pedals, that's the part that would actually dock to the space station. And the astronauts would exit through that hatch area at the bottom of the docking adapter. We'll get a look inside there once we go ahead and get into the tour. Okay, so Space Transportation System, in total 184 feet tall, 4.4 million pounds of weight at liftoff. Now the power system, 3 orbiter engines, okay, RS-25s, which now they're using for NASA's latest moon rocket. In fact, they're using some of the actual engines that flew on the shuttle. So total thrust for the orbiter is a little over 1 million pounds, fueled with liquid oxygen and liquid hydrogen. But the real powerhouses were the solid rocket boosters. Those are those large white cylinders on the side. And they used aluminum perchlorate composite fuel, and total thrust from both of the SRBs was over 5 million pounds of thrust. So they really did the bulk of the work in getting the shuttle off the pad and getting it upstairs. Total thrust at liftoff is almost 65 million pounds. So you've got 65 million pounds on a 45 million pound vehicle, and you probably remember that's a pretty good thrust to weight ratio. So the shuttle left the pad pretty quickly. It wasn't like a Saturn V or anything like that. So it could deliver 60,000 pounds to a low Earth orbit, less if they were going higher. Return capacity, as I mentioned, 31,000 pounds. Cost per launch, $450 million. That was one of the problems with the shuttle, because yeah, it was sort of reusable, but it wasn't reusable to the point to where they could really save any money doing it. Orbiter weight itself was 172,000 pounds, and you got to think about what an amazing machine this is, particularly when you think about when it was designed and built, right? So back in the 70s, I think the first approval for it came in 1972 when the Apollo 16 astronauts were walking on the moon. You're going 0 to 17,500 miles an hour in 8.5 minutes. You're going supersonic in 45 seconds. So this thing really got up and moved. Maximum crew size normally was 7. I think they could take 8 if they needed to, but I'm not sure that they ever did that. And this number down here, the L/D ratios, this is basically the glide ratios. And if you've ever flown an airplane or flown a glider, you'll know what these numbers mean. So basically, when you are hypersonic, it's 1-to-1. Its sync rate is very, very low. Once you get into the supersonic region, now it's 2-to-1. So every foot you go forward, you drop 2 feet. And then when you're subsonic, for every foot you go forward, you drop 4.5 feet. So that's kind of where it turns into a brick. Speed of touchdown, a little bit faster than an airliner. Well, quite a bit faster than an airliner, actually, at 220 miles per hour. First flight, April 1981. Last flight, July 2011. So 30 years. I mean, that's an amazing long time for any system to fly. 135 missions flown. Of course, 5 orbiters were built, 2 were lost, and 3 remain on display at various venues across the country. And because it flew for so long, you had a lot of firsts associated with the shuttle. First woman in space, first African American in space, first non-astronaut guest crew member, And the oldest person to fly in space, John Glenn, when he was, not John Lennon, John Glenn. It would be cool if John Lennon did get a chance to fly in space.
Imagine.
Unfortunately, that didn't happen at the age of 77. So, pretty amazing. So what?
Was the first gentleman in space.
Who was?
Gondola.
Oh, I should have amended that. First American woman astronaut in space, because you're exactly right. Okay, so now this is the part that we have to hope really works. And what does that tell me? No, I want to skip verification. Windows 11. Thank you very much. Okay, so. Uh-oh. I think I need to, hang on just 1 second, because I haven't tried this with projector. So we're going to close. I think the problem is that PowerPoint is open. All right, I need some help here because I have the tour on my screen, but I'm not getting it on the projector. Anybody have some ideas?
Control button that switches your output.
Is it like all tab?
Either that or turn the screen around.
Yeah, I may have to. I may have to. Sorry. There's always one. There's always one. How do you get this set up? There you go. That's just for that, though. That's where it is. Yeah, you're not. Here, let's go display. Really? Yeah, you're on extended display. Duplicate. Oh, there we go. Just okay. X out of that. X out of that. Yay! Thank you, boss. I've been saying,
I'm going home.
I was just thinking about standing up here for the next half hour and doing a song and dance for y'all guys. This is really great. All right, so here we go. On with the tour. Now, let me see if I can get myself in the right position here. Oops, that's not where I wanted to go. I'm still not quite adept with this system. Here we go. Okay, so when you first enter the shuttle, you're going to enter into the lower deck, or what they call the mid deck, and which was really the main living part of the shuttle. Okay, and you would come in through that round hatch opening that's about 3 feet wide. So it's not too bad, but it does take a little bit of a contortion to get through there. You kind of have to slide through. And keep in mind, this is not the orientation that the shuttle is in when it's actually on the launch pad, right? It's tilted up 90 degrees looking at the sky. So all of these things getting into the vehicle and getting to where your seats are, it's all a bit of a transition. And of course, there were people inside the vehicle to help you get situated. But the first thing I want to talk about, because the first thing that you see on the right-hand side is the shuttle bathroom. Okay, and on the right-hand side, you can see there's a place where we have towels and all kinds of nice things to clean up. And believe me, you are going to need them. On the back wall, you have all of your toilet supplies, and I'll get into that. And those black plastic cups, those are color-coded, and every astronaut had their own personal color. And that's where you would put your tissues and your personal towels and stuff like that, so you weren't mixing things up with other people. Now, it did have an attempt at privacy. This is a door, actually, that can close all the way, but you can't be on the toilet when it's closed because there's not enough room. So you kind of close it a little bit, and then there was a curtain on the side and a curtain on the top that you could deploy for privacy. Every astronaut that I've talked to that flown on the shuttle said they never used the curtains because it got in the way and it was just too difficult. So everybody got kind of used to that. If somebody was using the bathroom, you would find something really interesting to do up on the flight deck or whatever. So they kind of worked that out. So as you might imagine, going to the bathroom in space is no easy thing. You might not have given it much thought, but gravity helps us an awful lot here on Earth to make sure that things go where they're supposed to go, right? So first of all, you have the problem, you're not being held on to the commode, right? So there are special straps and footrests that you can use. There's a little belt device that kind of try to hold you down. The second problem that you have now, liquid waste is easy. You see that blue tube? Everybody would have their own individual funnel-like receptacle that would attach to the end of that blue tube. And then that's where your liquid waste would go. So think about peeing into a vacuum cleaner. Now, don't go home and do that, but that's basic.
Thank you for that warning.
Yeah, so basically,
Yeah,
that's what you're dealing with. But easy. It's similar to a system that they've kind of always used. But solid waste is a different problem because the first problem is separating it from you, okay? If you take a tube of toothpaste and you're in orbit, and you start to squeeze it, you're going to start to get this long strand of toothpaste. It's just going to get longer and longer and longer, right? You have to shake the tube to break it from the tube. Well, kind of the same thing with stuff coming out of you. So you have to wiggle around and kind of get it separated from you. Then the problem is, how do I get it going where I want it to go? And where I want it to go isn't on the ceiling, it's not flying across the compartment and that kind of stuff. And it's a real health hazard too, because fecal matter floating around in microgravity, if you could breathe that in, that could make you very sick. So it's funny, but it's also serious. So what they did, and this is the first version of the shuttle toilet, is they used airflow. They had airflow that was going down into the seat, so once you broke your stuff loose, it would go down through the hole. But its adventure is not over. This toilet is utilizing what they call the slinger design. So there's a rotating element down in the toilet. And so when the solid waste hits the fan, it gets slung and it sticks to the sides of that container. Okay, and then there's a little sweeper thing that comes and kind of just makes a very, very thin coating. At that point, you seal the toilet and open a valve and expose it to vacuum. Okay, so you're freeze drying the solid waste. So it gets all of the liquid out of it. It hopefully kills most of, if not all, of the bacteria, and you've got something now that you can deal with, and it isn't going to smell up the whole place. Although I was been told that it still didn't smell very, very good when you're close to it. But that's basically how the toilet system works. And as a side, it's interesting how they train to use this toilet. Because in Houston, they did have a toilet training room. And they had two toilets. They had a functioning shuttle toilet, and they had a trainer. And the trainer actually had a video camera below the seat looking up with a crosshair. So the first thing, and a screen right in front of you. And the first thing you had to learn is how to line up the relevant body parts to that crosshair. Because it's only a 4-inch opening, right? So you train on that. Once you were comfortable doing that, you go over to the real toilet and you would make sure that what you learned was correct. So there are times when being an astronaut is not terribly heroic, and this is probably one of those times.
They also use the Vomit Comet to train them.
Did they do it there too? Yep, that makes sense. Not surprised by that at all. Okay, so we are going to continue around here. And first of all, I'm going to kind of give you just an overall view of the lower deck here. And the entire shuttle, the entire livable area, is about 200 square feet, okay, of floor area. So if you can imagine spending 2 weeks with 6 of your closest friends in a 200 square foot apartment, right, with 1 bathroom, no shower, and the door is shut, locked. Okay? That's what you're dealing with when you're doing a mission on the space shuttle. So that kind of puts it all into perspective. So let's go ahead and move over here. And the other thing too, you'll notice this large aluminum panel. That's actually attached to the ladder that goes up to the flight deck. Because again, this whole thing is tipped up 90 degrees when it's on the launch pad. And this is a convenient little bench. So when you enter the vehicle, you can actually sit on that while you're getting weighted to being helped into your seat. So what we're looking at here, this is the basically your doorway to space. Okay, this is where you are going to go if you are doing a spacewalk, because this leads to the external docking adapter. And luckily, this little 360-degree tour will actually get us out there, and you can take a look at what it looks like. So this is this sort of not very large cylindrical structure, and then there's a vestibule out here, which is your final stop before you go all the way out. Now the suits were stored in here. The backpacks were attached to these aluminum racks. And so I can tell you that if you're in here with 3 people, it already feels really crowded. I can't imagine what it was like with 2 astronauts, 1 or 2 people helping them, the suits, the equipment, and all that stuff. Very, very, very tight quarters. Now, if we look above, that is the actual docking hatch. And so if you were docked to the ISS, this would be open, and that's how you would access, you would travel between the ISS and the Space Shuttle. The other thing that we had in here that was very convenient is we had the suit servicing panels. And so once you were done with the spacewalk, the backpack had to be replenished. You had to replenish the water, which was used for cooling. You had to replenish the oxygen, which was used for breathing, and you had to recharge the batteries and all that stuff. So all of the equipment that you needed to do that was right in here. So that was quite convenient. So let's go ahead and crawl out. If we can. Okay, we're going to go back, continue on around here. Okay. So yeah, so you're looking at, this is the first set of lockers, and you're going to see a lot more of these lockers. And they were used for a lot of things, to store clothing, to store tools, experiments, food, not a lot of food, and we'll get into that later. This sort of weird looking area back in here, this is where you stored the launch and entry suits. So you can remember those orange pumpkin suits and the helmets, all of that stuff would get stored back here once you were on orbit, because you didn't have to use that stuff again until you're ready to come home. Let's go back over here. Now against the wall here, you can see some you can call them sleeping bags. They're not really designed to keep you warm so much as they're designed to keep you sort of locked down in one place while you're sleeping. And sleeping aboard the shuttle was pretty open-ended for the most part. You could take your sleeping restraint and you could put it up on the ceiling, you could put it on the floor, you could put it pretty much anywhere that you wanted to kind of make that space your own. And I hear that sleeping in microgravity is extremely comfortable, because you don't have any pressure points on your body at all. And if you stay very still, it's kind of easy to get warm because there's no convection. And so the air will warm next to your skin, and if you don't wiggle around, it just kind of sticks there. And so you're kind of wearing this sort of invisible insulated jacket of warm air. So yeah, everybody that had that experience really enjoyed it. So we're going to kind of look at the floor. Well, maybe it's not the best place.
What would be the temperature of this room? What would be the temperature of this room?
Probably to whatever they set it at within a certain range. I don't know what they normally kept it at, because being in that environment, 68 might feel colder than you're used to or warmer than you're used to.
But it was heated.
Oh yeah, oh sure. Yeah, good airflow and stuff like that. Now, under the floor here, there's actually storage compartments. There was a lot of stuff that was actually kept under the floor that you would access through these lockers. And one of the most important things, you have to use lithium hydroxide to get the carbon dioxide out of the air, and they come in big canisters. And the canisters were stored here, and the receptacle for them was here. And you would run 2 canisters at the same time, and every 24 hours you had to change one canister for a fresh canister. And there are many other things that are down on the floor there. What I really want to talk about are these lockers. And this is really your main organized storage area on board the shuttle. Now, if we look back here again, this whole area, there'd be bags tied to the ceilings, to the walls. This is kind of like an apartment with no furniture right now, right? The chairs are not set up. None of your equipment really is there. But you'd be carrying a lot of stuff. But for things that really you needed to have organized storage for, you would use these lockers. And they had a really nice scheme. So MF is mid-deck forward, 28 is the column, and G is the row. So the ground could call up and say, you know, where's my toothbrush? Oh, it's in MF43G. So you know exactly where to go to find your stuff. And these are stickers that were actually on there when we received the vehicle and give you an idea of kind of what was in there. It was MS1 clothing, Commander clothing, and again, we see the colors. Everybody had their own individual colors. The way these lockers would work is you would undo the little clasp at the top, and it would fold down, and inside there would be a very lightweight aluminum blue drawer. Sometimes it'd be 2 drawers, sometimes it'd be one deep drawer that would have straps for holding things down and stuff like that. And that drawer would come out completely. Because you don't want to open a drawer in microgravity and have everything just fly out. And that would be very inconvenient. Also, up here, this area here, that's what the astronauts called the pantry. Because that's where they kept all the snacks and all the candy. So if you had a hankering for a little bag of Skittles or something like that, that's where you would go to find that stuff. Okay, so we're continuing to move around here. Now what we're looking at, this is actually the galley. This whole thing from here to here. And pretty straightforward. All of the food was pretty much prepackaged in plastic packs. If it had to be hydrated, you would stick the package into this little device here, pull the handle down. A little needle would pierce the package and inject hot water or cold water, and how many ounces, and you control that with this little panel here. This is a little storage area for the food packets as you're kind of getting everything ready. And typically, one person per day would be in charge of putting the food together for everybody. So you get everybody's tray, you'd stick them up on the lockers with the Velcro, and you'd start eating stuff up, and you'd put everybody's tray together. Below that, that's actually a little convection oven. So another way to heat up certain packets of food. So it's pretty complete. There was attachment for a water gun, so you had that. And so it pretty much did everything you needed to do as far as the food preparation goes. Now I'm going to kind of go a little bit sideways here. You see right here? Anybody have a guess on what that is? That's an air pressure gauge. And it's interesting because it reads from about 16 to 0 pounds. You see this little box right here? All right, so you open this box. There are warnings and all kinds of things in there because there are 2 handles in that box. The first handle depressurizes the crew compartment. Okay, and that's what this gauge is for. And the second handle blows the entire hatch assembly off the vehicle. So this would be used if you're coming back after re-entry and you're starting to fly and you're subsonic and you're not going to reach a safe place to land, you need to evacuate the vehicle. There'd be a pole that would extend out that open hatch opening, and you would actually slide down the pole, and then you would parachute down to wherever you were going to end up. So that was really the only way and the only time really where you could actually escape the space shuttle while it was flying. You could always do it on the pad with the escape slide system, but once you were flying, that's basically, whoa, wow, that was interesting. That's what you had, and that's why the pressure gauge is there, because the person who was in charge of doing that operation needed to be watching the pressure outside until it was close to being equalized, because you don't want the pressure to be too low. So that was a little thing that I got a lot of questions about. This is another storage rack. This held laptops, networking cables, switches, routers. One of the first things that they would do when they go on orbit, because it didn't really have, it had computers to fly the vehicle, but they didn't have a network. So they would have to string the wires and set up all the equipment and plug in all the laptops so that they would have a working network, because they used that a lot for the various experiments that they were doing. Okay, so that about covers it for the mid-deck. How am I doing on time, guys?
9:30.
Okay, good. Okay, so we are now, hello, we are going to climb up to the place that everybody wants to see, and that, of course, is the flight deck. And it's pretty easy to get up there. There are two openings actually in the floor. You can see the main one right there. You can see the main hatch opening below it. And there's also another opening on the other side. But this opening wasn't used to go up to access up and down. The first thing the astronauts would do when they got on orbit, they had a big box fan with a filter on it. And they would place it into that opening and get that started. Because once you reached orbit, there was all kinds of schmutz in the air that you really wanted to get rid of. And that fan did a really good job of getting all that stuff sucked down to the filter. Really improved the air quality in the shuttle right away. So let's go ahead and let's stand here. No, let's not stand there. So what we're looking at here, and you'll notice a lot of these blank panels. There was a lot of standard equipment in the shuttle that was always there. But these black panels, if you were flying a special experiment, let's say like a radar mapping mission or something, there would be extra, these would be filled in with the equipment that was needed to fly that particular mission. So you always had to have some blank areas. And you might you might notice that this looks pretty beat up on the inside because it was in use for a long time. But from what I've seen of the actual flying shuttles, they're kind of like that too. You can tell that they've been well used. Probably a little bit more here. So this black box right here, this is the downlink digital multiplexer. The space shuttle is filled with hundreds of different sensors that are always taking data, and you need to get that data down to the ground. So it takes all of those signals, puts it together into one signal, and beams it down to the ground. So very, very obscure, but very, very important piece of equipment. Now, as we come around here, what we are looking at, this is the station to control the Canada arm. You can see the controller, and that kind of swings over. And the Canada arm was a fantastic piece of equipment. And it actually, for a lot of things, it actually had preset movement programs. So you could punch up program 1 and it would go to a specified place at a specified attitude. So you had those built in for your mission depending on what you were going to do. But it was also possible to control the arm totally manually. And you could control each joint one at a time. And you had readouts, these 3 gauges right here for pitch, roll, and yaw on the arm. Because the astronauts really thought of the arm not as a bunch of joints and stuff, but they would always say, well, we were flying the arm, because that's kind of what the experience is like. You fly it to where you want to go. So roll, pitch, and yaw makes a lot of sense. And of course, with these windows up here, let's see if we can get up there. Yeah, we can. You can see that you've got a beautiful view right into the cargo bay. Those are those 2 little windows that you saw when we were in the cargo bay looking back at the docking adapter. And so whoever's operating the arm would be right there and operating the arm from that position. Let's go back to here. Okay. And the other thing that a lot of people don't realize, but if you think about it, it's pretty important. It's actually possible to fly the space shuttle from this station right here. So you can see that you have your controller that controls roll, pitch, and yaw on the vehicle. And then you have what's called a translational controller. And so this basically is movement forward, back, left, and right, up, and down. So you kind of click that depending on which way that you wanted to go. So you would actually use those 2 controls in tandem when you were docking to something like the International Space Station. You had your cross pointers, you had an 8-ball right there. Basically everything you needed to execute that kind of a maneuver. Let's go back over here. All of your radio communication equipment, FM, S-band, all that stuff was controlled off of this panel. A large part of this panel was actually used for processing video, sending it down to the ground, powering power cables for video cameras. This is kind of the imaging section. But I want to draw your attention to right above here, these funny looking bags that have numbers. And you might notice, because there's a set on the other side, that we have 7 bags. So that matches 7 crew members. Every crew member has a bag. And these bags held what was called the Sky Genie escape system. Okay? It's actually a commercial product that was originally developed for airline pilots to be able to escape from the aircraft. Basically, it's specialized rappelling gear, okay? So, and it's interesting because there was only one time when you could use this. You would have to be on the runway, stopped, then you can use it. I think this is kind of a throwback to the Apollo 1 fire. They didn't want to have a vehicle where, even if it's sitting on the runway, that there's no way to get out of it. So if there's a fuel leak, if there's a fire, you can get out of it. What'll happen, the outer panes on these upper windows will get blown off the shuttle. And this one will actually hinge down. And that's kind of handy because you're going to need to climb out that window with your Sky Genie, and you're going to have to go over and you're going to have to rappel down the side of the vehicle to the ground. And that's why, remember I mentioned earlier that it's at the same height and attitude as a landed shuttle would be? That was the reason for that. So when you're doing that Sky Genie escape training, it's going to be exactly what you're going to experience. And I've seen video of John Glenn doing it. He wasn't very good at it for some reason. He would just spin around and around and around and around. But you know, he finally got it. Yeah. So that's just one little thing that is kind of interesting. And like I say, it is a commercial product. There's another commercial product in the vehicle on one of the, they call it a Duffy vent, which is part of their air circulation system. And the register for that Duffy vent is a part for a Toyota Corolla. I don't know what year, but that's where they got it. So NASA doesn't always waste your taxpayer. Sometimes they do. All right, so now what everybody's really waiting for, we're going to talk about the flight deck. So, very interesting. And I've been in here with a lot of pilots, and they all, once they get up there and look at this, they are instantly in their element. Because this is really very similar in size, not in layout and instrumentation, but in size and in general, how it functions to a commercial airline cockpit. The pilot would be in the left seat, the commander would be in the left seat, the pilot would be in the right-hand seat. And just a general overview, you had the APU controls over here, electrical controls, and a lot of other controls. This center console had a lot of the abort controls, so you could shut down engines, you could release the external tank, you could release the SRBs manually if you needed to, and all of that stuff is right down here. But what I really want to bring your attention to are these keypads and these three screens. Now, not everybody might realize this, but the Space Shuttle was aerodynamically unstable. If you were subsonic and you tried to fly it manually, you would lose control within 120 milliseconds. Okay? So the shuttle has to have a fly-by-wire system. And what fly-by-wire means is that if I tell the vehicle to pitch up, all right, what will happen is that signal will go to the computers. Computers will look at it. They'll translate it, put it onto move the hydraulics so that action happens. But at the same time, they're making thousands of little corrections to keep the thing stable. Okay, so it's a complete fly-by-wire system. And there were 5 computers on board the shuttle. And these computers were not designed to be fast. They weren't designed to have a huge amount of memory. They were designed to be incredibly reliable. They were made by IBM. Similar computers were used on the F-15, on the AWACS. They were also used on, where am I thinking? They were also used on Skylab, at least a slightly different version. So the way it would work is if I made an input, if I made a control input, 4 of the computers, because they're all running at the same time, but 4 of the computers had exactly the same software, and all 4 computers would look at that command, and they would come up with an answer that then would go to the control bus, right? They had to agree. If one computer didn't agree, the other 3 computers would look and say, oh, okay, something's messed up here because we agree, and they would reject that output. And the commander would get a warning. He could look on a matrix above him, and at his discretion, he could actually take that computer offline if it was repeating this kind of an error. So you could lose computer 4, you could lose computers 3 and 4, you could lose computers 2, 3, and 4, and you had 1, you're still good, okay? Well, what if I lose all 4? That's what number 5 is for. Exact same computer, but it's running a reduced subset of instructions basically the bare minimum that you need to get into orbit and the bare minimum that you need to get back down to the ground. And this software, the software guys appreciate this, was written by a different vendor. So again, you know, another sort of level of safety, so you're not going to be propagating mistakes that might be in one set of software to another set of software. And the way that system was initiated, there's a switch on these controllers that takes a force of 8 pounds to press. So to press that switch, you really want to press that switch. You're not going to press it by accident. And as soon as it does, it instantly changes over. Because that computer is running along with the other 4 all the time. It's ready to kick in. So pretty amazing system, and the Space Shuttle needed it. Now, once they were in orbit, those 4 computers could be used for other things, orbital calculations and what have you. So it's a pretty interesting and pretty complete system. And also, once you're up here, let me show it now a little bit. The view is tremendous, to quote John Glenn. These windows are huge. And you can just imagine sitting in one of those seats, and the kind of view that you would have of space and the Earth would just be remarkable. Along with those overhead windows that are back behind them. I mean, just a great place to be. So let's go ahead back here, and we're gonna go right here. How are we doing on time, guys?
About 3 minutes.
Okay, so that really pretty much completes our tour of the Space Shuttle. So let me go ahead and we'll just open it up to questions and see where we go with that.
So I take it the mission specialist seats are stowed in training.
Yeah, right. There were no seats down in the mid-deck. We had them up for a while, but they just took too much room because we were getting more than 7 people in there at one time. And we didn't really want people sitting in the seats because they were actual seats, and they actually put a bar between the seats. You can kind of see it right down in here between those seats because people were climbing up there and trying to get into that position. So yeah, like I said, it's kind of like a house with no furniture, you know, in the back. I know you had.
That was basically my question, but they were sitting like right behind the pilot and co-pilot?
Yes, there would be 2 seats that would be in this position back here. So you'd have a total of 4 on the flight deck, and then there would be 3 more down in the mid deck. And different arrangements, but that's the arrangement that they flew with most of the time. So you figure once you have the seats in there and people in there and all of the equipment and storage bags and everything else, it's pretty tight. For as big as the vehicle is, it's pretty tight for 7 people in there. Yes?
Who's the general contractor?
Chris, for the orbiter itself?
Yeah, the whole operation.
Well, the whole operation would have been administrated through NASA, but the individual components were supplied by various subcontractors.
Yeah.
So Thiokol for the solid rocket boosters. Who are the others?
North American did the shuttle itself, and obviously about 1 billion contractors that were for the individual components within it. So, and then operating the shuttle was essentially United Launch Alliance,
Yeah.
along with obviously NASA oversight. So I'm not sure if that's what you were looking for.
So a lot of entities, a lot of different companies were involved. IBM did the computers. So a lot of contracts flying around. Yeah.
How many of the astronauts got motion sickness?
The best number I've heard, about half.
Yeah.
About 50% of the people who fly in space don't feel that great for the first day or 2.
Okay.
Because once you get into microgravity, fluid redistributes, you get puffy in the face, you start looking a little bit Asian, you get a stuffy nose, that kind of thing, and you might be feeling nauseous. So first day or 2, you kind of want to take it easy if you're experiencing those symptoms. But yeah, about 50%. So it's definitely a thing. Yeah, Mike?
There's a movie called The Core with Hilary Swank where she's flying the shuttle back, has a problem, fires up the engines, guides that thing, lands in the LA River. How realistic is that?
It's not, because if you remember, once the shuttle reaches orbit, it drops its external fuel tank. So the 3 engines that are back on the orbiter at that point have no fuel. So there's no way that you could fire those engines up. Now there are 2 other smaller engines which are called the Orbital Maneuvering System engines, or OMS. And those are the engines that you would use to raise your orbit or lower your orbit, that kind of thing. But they're not powerful enough to be able to do what she did and couldn't run long enough. So that was totally fictional, but made for a good movie, so there you go. Yes?
What secret are you hiding in that blurred out area?
Well, if you can imagine, if you're taking a 360-degree photograph, right? You're doing this, well, that's, yeah. They're not trying to hide anything, they're just, because you can see what's down there if you just change your viewing position. Got a question over there?
Yeah, you have several photos here with the stuff blurred out. What kind of equipment was classified back then that it's got to be blurred out today?
Blurred out where?
Right there.
It was the same question you just got, and you answered. It's just the way that the 360-degree photo machine works.
Oh, it's
it blurs out what's below you.
intentional blur.
It blurs out what's below you.
Yeah.
Oh,
There is, believe me, I
Thank
was
you.
never
I got
exposed.
hearing aids.
I don't have a clearance. I was never exposed to anything that was remotely classified. Although the shuttle did do a couple of missions for Department of Defense and flew some payloads for them. And those particular missions is very hard to get information on what exactly they did because a lot of that was classified. But for the most part, yeah, no. Yeah.
Actually, I worked in Los Angeles when they brought the shuttle back to Exposition Park. And before it was put on public display, they brought it to one of the defense contractors to remove classified information out of it.
Sure, I believe it. Yeah.
So, where, obviously no one knows what it was, but what do they put in place of the stuff they pulled out? Do they just put like TV screens or like gauges in?
Well, if it was something that was visible in the crew compartment, they would, and if they wanted people to access the crew compartment for any reason, they would just do a mock-up
Okay.
and put that in place, and you wouldn't know.
But it was either like Lockheed or one of the defense contractors that had it stay there like 3 months for them to pull all the stuff they didn't want the public to know about. So.
Yeah, so I can tell you there's nothing in the trainer that even remotely was like that. Because we pumped, before they closed it down, we pumped thousands of people in through here. Bill Gates, we put in there. That really tall late night host, Conan O'Brien, he did a tour. We had a lot of fun. It was really
But for
interesting.
people who don't know the size of it, when they brought it down LA streets, the
Yeah.
Coliseum,
Oh, yeah, yeah.
the infrastructure, they had to move the traffic signals, power lines.
Yep.
And, you know, streets are not designed.
See, they should have they just should have delivered it to Seattle. You know, we got a big, beautiful road. It's so easy.
So LA has, just another question, so LA has one of them, where are the other shuttles located?
One is at Kennedy Space Center in Florida. I know the Enterprise, which is the one that didn't fly in space but was used for the drop test, that's in New York. And what am I missing, Chris?
The National Air and Space Museum.
Yeah.
Yeah.
So that's all.
Rich guy.
Discovery's in DC. Enterprise is in New York. Atlantis is in Florida.
Yep, exactly. But don't mean to be sour grapes, but we built an entire temperature-controlled building. We were ready to go.
Oh.
Very sad. But the trainer was actually probably for a museum an actually more useful piece. It doesn't have the gee whiz, but the fact that you can actually do it is a whole different dimension. It's a whole different experience. So, yeah.
When they flew HST, how much actual space was left in the cargo bay? Could people be in there doing something with the scope or not?
It was pretty big. I think it took up pretty much all the space in the bay. Yeah.
It did.
And it also had that platform that would actually tilt it out and actually deploy it. So it wasn't just the telescope itself, but also that equipment too. So yeah, that was a very, very large payload. I don't know how much it weighed, but it was probably close to the payload weight limits that they actually had. So yeah.
I used to work range optics, and when the shuttle, when Kennedy was socked in with weather, and they were going to land, we were talking about landing here at White Sands, I was out at the end of the runway with a bunch of cameras. But we were told once the shuttle stops, we were supposed to stop recording because we were not supposed to take pictures of the astronauts getting out of the shuttle. I was we never found out why we were told that. Do you have any idea?
Well, that's kind of weird because they broadcasted that live on TV with them coming out of the shuttle. So I don't know what they were trying to hide from you guys, but they weren't hiding it from me.
We always figured it was aliens.
Yeah, no, I don't think so. That'd be really cool, but I can't imagine. Yeah. So it was.
We were so disappointed.
And you know, with the landing that they did have out here, the reason that they never even considered doing it again, because they were forever getting the sand out of that vehicle. And every time they recycled it, they found more and little nooks and crannies, and it just got into everything. So yeah, they didn't. They would only have come back here if they had no choice. It was the only thing they could do. So yeah, yeah.
The only problem that I seen of all the years that they used the Space Shuttle was the tiles. The tiles were constantly being removed, replaced, and evaluated for why did it fail?
Right.
Why?
After I should have brought a tile today. This should have been really nice. But if you can imagine a piece of styrofoam covered with a very, very, very thin coating of basically glass. If you dropped it, it would be similar to like an old-fashioned Christmas ornament. These were very, very fragile things. And so it didn't take much to damage them, as they proved with the loss of Columbia, right? So they were always a worry. They were very hard to develop. And I don't think that we would do it exactly that way again. If you look at Starship, it still has tiles, but they're a different material, and they're all exactly the same shape. On the Space Shuttle, every tile was unique. And after every flight, they would go in. This was part of the turnaround time, the turnaround cost. They had to do a pull test on every tile. They had to inspect every tile, and they had to replace the tiles that, and it took hundreds of man hours just to replace one tile.
You just answered my question.
Yeah.
I got there, it was a long inspection.
Yeah.
From launch to coming back to Earth to actually being ready again.
Yeah. It took a lot of people, a lot of man hours to get one of these orbiters ready to fly, and it really did. And the shuttles, when they ferried the shuttles from California to here, the first time they did that, there was a whole bunch of tiles that were missing just from flying on a 747. So, how are you going to go into space if you can't even deal with those kinds of speeds and vibrations? So, yeah, that was really probably the toughest part of the shuttle to develop and actually make work. But it was always a concern, and it was always a worry.
Was there any historic satellites that were launched during the time that the Space Shuttle mission was going on?
Oh God, that's a good question. I don't have the answers for you. A lot. That's a Google thing. In 30 years, yeah, there's going to be a lot of action. So, do you have another question?
Yeah, I did have another question. So when they built this, those 5 computers were 1977 technology. And I understand that they're all very interconnected with one another and with the whole system as a whole. But as computer technology advanced, did they ever try to go in and update it, or did they just stick with what they knew worked?
That's a good question, because the space shuttles went through a major upgrade. It was sometime in the 90s, Chris, is that right?
It went through 3 iterations,
Three?
and it's very interesting. If you go back and look at the shuttle when it first flew and the cockpit layout,
Which is what you're seeing here.
yeah, that's actually no, that's a little further on.
Is
so
it?
if you go back to the first iteration, and you go back and look at submarines that were built at the same time, the first 688 Los Angeles class submarines, the ship's control panel and the shuttle thing look exactly the same. Then eventually when they went to a glass cockpit, which they had towards the end, and you start to see here, and they changed out all the computers, etc. So it changed in aircraft that the military was building, submarines that the military was building. It's all about the same technology. They look exactly the same, but yeah, it went through a few iterations.
And they did a computer upgrade. They didn't change the computers. The original computers had something called rogue core memory. And basically these are little magnetic donuts with wires being woven through them, and depending on how you weave the wires through, it would be either a 1 or a 0. And it's, that was your memory, because it was extremely reliable. But to actually get your program in there, you actually had to weave, right, the program into the kind of amazing stuff. That's what they used in Apollo. But at some point during the shuttle program, they actually upgraded the memory for the computers. They went to, I think, 1 megabyte or 1 gigabyte. I know that's a big difference, but they went to a 1 something. So they did it, but they didn't really need that much memory. Calculations that they couldn't do on board, they could do on the ground and just give them that information. So somebody here, anyone? Okay.
Well, I have a question.
Yep.
I noticed that it was the original flight deck. If you go out and look in the elevator, you see the latest flight deck.
Right, that's a good point of comparison, because these 3 screens, these are still cathode ray tubes. They're not flat panels. But the 8 balls, they basically went to a full glass cockpit configuration. And even on that aft control station that I showed you, that's behind there, the 8 ball was now a flat panel. All of the readouts were flat panels. So just a lot later, less power usage, all that kind of good stuff. Yeah, wrap it up. I'm getting the sign. I'll do one more question.
I was gonna say, a lot of that, when they switch it, is weight saving so they could go more payload.
Yep, I'm sure it paid off, yeah. I think if you look at any vehicle, like if you look at the lunar module, I mean, that went through an evolution where they could get more and more pounds down onto the surface of the moon, so that we would eventually be able to carry the lunar rover, extended stays, that kind of thing. Same sort of progress with the shuttle. Okay, so I'm going to bring the talk to an end. Thank you all very much for coming this morning. We appreciate having you. And at this point, I'm going to ask Chaplain Harper to come up and fill you guys in on what's coming up at the museum.